No. A random sample is conducted. Based on the sample, it is estimated that the proportion of the population that has a certain characteristic is 0.37, with an associated margin of error of 0.09. Which of the following is most appropriate? Okay. So the answer is, well, not the answer. The given amount that they found to be true. Let's say it's that people own, what would something a third people own fish, like have pet fish or something. Okay, so 0.37. All right. Okay, so 0.37. So the margin of error is 0.09. That means I need to add and subtract that amount from 0.37 to get a range of scores that would be appropriate. Because 0.37, if you're talking to a sample, there is some error in that, okay? So if I add, and make sure you line up your decimal points when you are doing this with decimals. If I add 900ths, that means the upper number is going to be 0.46. If I take 0.37 and I subtract 0.09, that means I have to borrow, and of course you could do it on your calculator. That means the bottom amount would be 0.28. Okay, so it goes from 0.28 to up to 0.46. Okay, so these are the choices that we have. It is plausible that the proportion is less than 0.28. No, this is the appropriate range. So it can't be less than. So it's not going to be that one. It is possible the portion is exactly 0.37. It says which is the most appropriate. It could be, but that's why we have a margin of error. So it is plausible, but that is not the best one, I don't think. So let's look at the others. It is plausible. Plausible means like possible. I don't know why we use plausible. Maybe that's a data statistic thing. That the proportion is greater than 0.46. Well, this is the upper amount, so it's not greater. And the last one, it is plausible that the proportion is between 0.28 and 0.46. Yes. So the best answer there is this. Yes, it is plausible, but it says the most appropriate. So that one is not most appropriate. Okay. All right. Questions on that? Antonio, does that make some sense? Hope so. Okay, let me check something here. Yes, you're welcome. All right, anybody else have a specific one that they would like to see, or should I just go back and to where we were at? Anyone? Bueller? Anyone still there? All right. If you don't tell me, I'm just going to go back to this other one. All right, so here we go. Number 13. A spinner is divided into 5 equal sectors or sections. A sector is a section, but sector is the correct math term for it. Okay, the spinner is spun 100 times. The table shows the number of times the spinner lands on each color. This is a frequency table. Okay, and if we were to add all these up, it should add up to 100. So 17, 20, 21, 30, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it does. Okay. Calculate the theoretical. That means in the mind what it should be, not what it was, but what it should be theoretically, okay, of landing on red. Well, if you have 5 sections, 1, 2, 3, 4, 5, there's 5 total. What's the probability? That means numerator over denominator of landing on red would be 1 out of 5. Because you have 1 red and you have 5 sections total. Okay? Now, letter B says calculate the experimental probability. This is the experimental right over here because we did an experiment 100 times and these are the results that we got. So we are looking for yellow. Yellow. So the experimental probability means I landed on yellow 21 times out of 100 total. Okay. How did I get 1 out of 5th? 1/5. Okay, good question. So 1/5, up at the top, it says the spinner is divided into 5 equal sections. So there was a color of red, yellow, blue, green, and black. Theoretically, you know, if I spin that spinner 1 time, I should get a probability of getting red 1 out of those 5 sections. You know, if I spin the spinner, it should have a probability of 1/5. Just like if I flip a coin, the probability of getting heads is 1 out of 2. There's 2 sides, heads is on one of them. Spin the spinner, there are 5 sections, red is on 1. So it should be 1/5. But experimentally, you don't always get what you should. Did you add the results to get 100? Yes. And it also told me here. Okay. Also told me here. Yeah. Yep. Okay. So then letter C says, using what you know about the law of large numbers, how many times would you predict the spinner would land on green if the spinner was spun 500 times? Okay. So 500 times, that's the number of times we're going to multiply it. What we need to do is use the experimental probability because we've actually done the experiment. We have done a lot of the spinning and we came up with 21 out of 100 times. So you need to use, with the law of large numbers, the experimental probability. Okay? And multiply that by, in this case, 500. Now, you might not remember, but you can, as I'm going to make this a little closer, you can simplify this a little bit. Sorry, I have a little cold and a little cough. 2 minutes to go. So to simplify multiplication, you can move around numbers. So we can move the 500 and the 100. I'm not going to say that. You can use your calculator, but basically you have 500 divided by 100. So that's going to simplify to be 100 goes into there once, 500 goes in there 5 times, 21 times 5 is going to be 105. Oh, wait a minute. I need to back up because that was for yellow and maybe somebody's saying that. Somehow, every time I do this, I lose my chat. Oh, okay. Yes. So, sorry. And this is what is a little bit different It is the experimental, but it is not the experimental of yellow because it says green. So don't be like I did just now, okay? Green is 18 out of 100. So sorry. Times 500. And I can put that 500 over 1. And I can put these two and extend this. So it's almost like 500 over 100. All right? So I can divide 100 into 500. 100 goes into 100 once. 100 goes into 500 5 times. And 18 times 5 is going to be 90. So that means I would get green 90 times to get green. All right. So don't forget there is an online Canvas activity. And hopefully I will see you in person tomorrow. Thanks. Bye-bye. When is the next class? 10:38 to 11:06. It is 6th period. Okie dokie. See you guys. Bye-bye. Bye. Take care. You too, Antonio. Hopefully I'll see you tomorrow.